Now we are starting with the third type of load, that is uniform varying load or UVL or triangular load. So what is it? Here the load is not uniformly distributed. Here it is uniformly varying, like 0 at one end of the beam and W at the other end of the beam, small w. So it is called a triangular load. Here the total load is calculated by the area of the triangle. That's why it is called triangular load. So here what is the area? One side, that is height, it is W, and base it is L. So total load is W half into WL. Okay. So for this case, here the load is gradually varying, gradually increasing from B to A. So here there is rate of loading. Okay. So what is the rate of loading? Here you need to calculate it, but unitary method, it is very simple. I think you can do it yourself also. That for length L, the load increases W, and for unit length the load increases W by L, and for length X the load increases W by L into X. So here also we have taken the point capital X and distance small x from point B. So what will be the load up to point X? The load up to point X will be this height at X. Height at X will be this, because the load starting from 0 has reached to W by L into X at point X. So height is W by L into X and the base is X. So the total load at X is half into W by L into X into small x, this base, that is written here. So it is the shear force at this point X, and it is applying at the right hand side of this point. So according to the sign convention, any downward force in RHS will be positive, so it is plus. So now what will be the bending moment at point X? The bending moment will be this total load and the perpendicular distance at which the load is acting. Here the load is acting at where? The load is acting at the centroid, center of gravity of this triangle. So it is at X by 3. We all know that the base is if it is a rectangular triangle, then the length of centroid or center of gravity will be base by 3, so X by 3. So what will be the moment is total load, that means this Fx into perpendicular distance, that is X by 3. So this now it is downwards. For bending moments, any downwards is negative, so the sign is minus. So that is the shear force at point X and bending moment at point X. So now here in case of shear force, you can see this equation is a second order equation. The power of the x is 2, so it is a parabolic curve. So shear force diagram will be a parabolic curve, but the bending moment, here the power of x is 3, so it will be a cubic curve. It means y equals to x cube, this type of curve. So bending moment will be a cubic curve. It will be more steeper, more curved like cubic curve. So the SF diagram will be like this and BM diagram will be like this. Now what will be the SF and BM at point A? You just replace this small x by L, because at point A, when the point capital X reaches at point A, the distance x becomes L. So by replacing replacing x by L, you will get the equation, the value of shear force and bending moment at point A. So that is WL by 2 and minus W L square by 6. That is positive and that is negative. So this is the example of basic type of UVL for a cantilever beam. So there can be another variation of UVL for cantilever beam, that is at first, as it is your basic knowledge, first class, so try to clearly understand this. We will discuss the second type later on if we get the additional time. In the second case, what happens? The load starts from the fixed end and varies uniformly and reaches at W at free end. So load at free end is W and load at fixed end is 0. So you can do it by yourself also, and we will discuss in later on after when you have be very much familiar with the initial concept. After that we will discuss this. So try to understand all these things which we have discussed in the first class till now. Okay.